Hello students, today we will see the theory part 4 of the some basic concepts of chemistry. Disclaimer, the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is experimental. Today's objective would be covering atomic mass, average atomic mass, molecular mass, and formula mass. Then we will try to understand a very basic and also a very crucial concept of chemistry, which is mole, along with the molar mass. Now, if I try to break it in the form of index, then we will get first of all the atomic mass. Then we will move to average atomic mass, molecular mass, and formula mass. Then we will cover a question related to this concept that we will cover, which is our in-text question. And in the next part, we will cover the mole concept and the molar mass. First of all, let us try to understand that what is atomic mass. So in the present system, the atomic mass is based on the carbon 12 as the standard. So this was agreed upon in 1961. Now there were a series of events which gave the conclusion of taking carbon 12. Before that, the scientists have tried to keep hydrogen and also oxygen as the standard, but due to some reasons, it didn't work out well. So we have to stick to the carbon 12 isotope. Now, here we are writing carbon 12. What does it mean? It means that we are taking the 12C isotope of carbon. So there are many more isotope of carbon, like the 14 carbon 14, which is radioactive in nature. So to specify that we are doing our standard calculation using this carbon 12, we represent it as 12C, where 12 is the molar mass of the carbon. We will see it, how it is the molar mass. So in this system, the 12C is assigned a mass of exactly 12 atomic unit, which is represented as AMU. And the mass of all other elements are calculated by taking the relative mass to this 12C standard. So this AMU is basically the unit that we are using for the calculation of masses of the small entities like atoms and molecules. What is the definition of this atomic mass unit? So its definition goes like, it is the mass which is equals to 1/12 of the mass of a carbon 12 atom. So we take the mass of a carbon 12 atom and divide it by 12, and the mass that we get is defined as the atomic mass unit. So this 1 AMU is equals to 1.66056 into 10 to the power minus 24 gram. So this is the one atomic mass unit mass. Okay. Now, we know that with the help of spectroscopic method that the mass of one hydrogen atom is 1.6736 into 10 to the power minus 24 gram. So how we will calculate the atomic mass unit for the hydrogen atom? So it's very simple. We know that the mass of one atomic unit is this much. Okay. So using the simple unit conversion, we can divide this whole thing by the mass of hydrogen atom to get the mass of hydrogen atom in terms of AMU. So it's very simple, right? Since 1 AMU is equals to 1.6736 into 10 to the power minus 24 gram. Therefore, in 1.66056, it will be 1.0078 AMUs. So if you go back and look at that unit conversion, you can easily calculate this value. Now we have approximated it to 1.008 up to third decimal, and AMU is the unit. Now, this same methodology can be applied onto the oxygen atom, and if we take the mass of one oxygen atom in place of this 1.736 into 10 to the power minus 24, then we will get the mass of oxygen atom as 15.995 AMU. So again, this value can be approximated to 16 AMU. But in the recent time, this AMU is being replaced by the U, which simply means unified mass. So we have dropped the atomic mass unit. Its value is same, only the way of writing has been changed to small u rather than AMU. But here, one thing should be considered, that whenever we are saying that some given value is the atomic mass of an element, it means that we are describing the average atomic mass. Now, why do we need this average atomic mass? We will see it. So, the need of average atomic mass was there because one element can exist in more than one form, which are called the isotopes. Okay, which are called the isotopes. So what are isotopes? The isotopes are the element which have the same atomic number but different atomic mass. So when we will learn about this atomic number and atomic mass in structure of atom, you will see there. For the time being, you can think of isotope as a variety of the same element but with a different mass. Okay, means the chemical properties are same. There is a slight difference in the physical properties if we are considering the isotope of an element. Now, if I take an example, then carbon is the one which is having an isotope, and it has actually 3 isotopes. So what I was saying is that if you take a sample of carbon, then it is very much possible that your sample would not only contain carbon 12, it will also contain the other isotopes. So in that case, what we do, we take the average atomic mass rather than the atomic mass. And this average atomic mass is used everywhere in your calculation. So for that reason, we simply call it as the atomic mass by dropping the average word. So you don't have to worry about this new term. It is just your atomic mass that you are dealing with. Now, if I try to tabulate the relative abundance of the isotopes, then we can do it in a way which is this. So there are three isotopes: carbon 12, carbon 13, and carbon 14. In carbon 12, the relative abundance is 98.92. Relative abundance means if you are talking about the whole percentage, then out of those, 98.892% is 12 carbon on the earth. 1.108% is the 13 carbon, and 2 into 10 to the power minus 2 is the 14 carbon or carbon 14. Now, I have told you that each of these have a different mass. So, it is being written here. If you calculate their atomic mass unit by using the same calculation that we have used, by taking the mass of one carbon 12, 13 and 14 atom, then you will get 12 atomic mass unit or 12 unified mass for the carbon 12, 13.0335 for the carbon 13 and 14.00317 for the carbon 14. Now the problem here is that which mass you should take. For that, we calculate the average atomic mass as follows. So the formula goes like this. It is simply the relative abundance multiplied by the atomic mass. So remember, we have taken the relative abundance, not the percentage relative abundance. So this thing is just divided by 100 to give the relative abundance, which is equals to 0.98892 multiplied by the unified mass of the carbon 12, which is 12U. Again, same thing with the relative abundance of 13C multiplied by the atomic mass unit of the carbon 13. And lastly, so same thing with the carbon 14, which is 2 into 10 to the power minus 12 multiplied by 14.00317 unified mass. So this calculation will give you your average atomic mass. This comes out to be 12.0110 unified mass, and you can see it very clearly that this value is approximately 12. Now, why it is coming out as 12 and why we are taking the relative abundance? So the answer is very simple. We are just focusing on the majority of carbon which is present, and that majority is being simply voted to this carbon 12, whose relative abundance is 98% of the total carbon. Therefore, our final value is also close to the 12. Okay. Now, we will move to a next term, which is molecular mass. If I simply define the molecular mass, then it is the sum of atomic masses of the element present in a molecule. So, atomic mass is defined for an atom, and molecular mass is defined for a molecule, in which we take the individual contribution of each atom in terms of their atomic mass unit or unified mass, which is the latest way to define the AMU. How it is obtained? So we simply multiply the atomic mass of each element by the number of its atom. So we are multiplying the count by its mass, and then we simply add it together. For example, if we are trying to calculate the molecular mass of methane, then the formula of methane clearly depicts that it has one carbon atom and 4 hydrogen atoms. Then how can we calculate it? So it can be calculated by using this method, which is multiplying the number of atom by the atomic mass of each atom and then summing them. So since we have one carbon, so we are taking 12.001 multiplied by 1, that would give you the same thing. Then we have 4 hydrogen, so 4 multiplied by 1.008 unified mass. This calculation will give you 16.043 unified mass as the molecular mass of methane. Now remember one very important thing, that what is the unit of molecular mass? It is unified mass. What is the unit of atomic mass? It is unified mass. Or in some cases, if you get it, you will see AMU. But the latest convention goes along with the U. Now, same calculation can be done for the water also, which has 2 hydrogen atom and 1 oxygen atom. Therefore, 2 multiplied by the atomic mass of hydrogen plus 1 multiplied by the atomic mass of oxygen. Atomic mass of hydrogen is being calculated earlier. It is 1.008 U. And this thing is also being calculated. So 1 multiplied by something will give you the same thing, 16.00 U. If you do this summation, again you will get the molecular mass of the water, which is 18.02 U. Again, I am making you remember that U, or the unified mass, or the atomic mass unit AMU, is the unit of molecular mass and the atomic mass. I hope you are getting the point, because now we will move to a same thing but with a different approach. So that thing is formula mass. Now, some substances like your sodium chloride, they do not exist as molecules. Okay? Basically, their constituent particles are not molecule. So therefore, we can't use molecular mass for the sodium chloride like unit. Now, for those type of compounds, we have the formula mass. For example, if I take the example of sodium chloride, then sodium chloride is composed of sodium ion, which is positively charged, and chloride ion, which is negatively charged. Now, this thing is arranged in a manner to give us a 3-dimensional structure, which is this. Okay. So the big balls are representing the chloride ion and the small ones are representing the sodium ion. This is a formula unit of sodium chloride. Now here, 1 sodium plus ion is being surrounded by 6 chloride ions. So this is basically the arrangement which has been described here. And same thing can be said for the chloride ion, that is, it is surrounded by 6 sodium ions. Now in this entity, you can clearly see that we don't have a existence of what? A molecule. Instead, it is a formula unit. Therefore, for the case of sodium chloride, we define formula mass, which is calculated in the same way as the molecular mass, that is atomic mass of sodium plus the atomic mass of chlorine. Since we have 1 as the stoichiometric or the count, therefore we don't have to worry about the multiplying factor. We are simply adding here the atomic mass of sodium and the atomic mass of chlorine. Then we get 23.0 U, which is the atomic mass of sodium, plus 35.5 U, which is the atomic mass of chlorine. This will be equals to 58.5 U. So this value is equals to the formula mass of sodium chloride. So remember students, every time you see a ionic compound like sodium chloride, you will not calculate the molecular mass, you will calculate the formula mass, but in the same way. So this is a better scientific approach rather than considering each thing as a molecule. And again, this can confuse you in the exam. If you are used to the molecular mass term, then while calculating the formula mass, you will face difficulty if you are unaware about this term. Okay, and you will simply lose marks on the simple thing. Now we will see a question related to the discussion that we have. Question says that we have to calculate the molecular mass of the glucose whose formula is C6H12O6. How we will calculate it? We will use our formula, which is atomic mass of each atom multiplied by the count, and then we will sum it all. So let's see how we will do it for the case of glucose. So we have multiplied 6, which is the number of carbon atom, with the atomic mass unit or the unified mass of carbon. Then we have multiplied 12, which is the count of hydrogen atom, with the unified mass of hydrogen, and again 6, which is the count of oxygen multiplied by the unified mass of oxygen atom. If you carry out this calculation further, you will get the molecular mass of glucose as 180.162 U. Again, remember, the unit here is very, very important for you. Okay. Now we will move to a very important thing known as the mole concept. First, what is the definition of the mole concept? It goes like 1 mole contains exactly 6.0221467 into 10 to the power 23 elementary entities. Now, this is one of the SI unit and is simply used to assign the amount of substance. What? The amount of substance. So while doing the calculation, we drop this part after the third decimal, which is 2. Okay, we drop this 14076 as a whole, and we only take 6.022 into 10 to the power 23 as our calculational part. Now, this number is fixed and is called Avogadro constant, represented as capital N with a subscript as small capital A. Okay, and its unit is per mole. Now, this is also called the Avogadro number. So both the unit, which is per mole, and the symbol capital N with a subscript of capital A is important. Now, how do we get this Na value? Again, this is in reference with the carbon 12 atom. So basically, what are we trying to do? We are trying to calculate the number of atoms in 12 gram of carbon, which is the numeric value of the atomic weight of carbon. So first of all, for that, we must know that the mass of one carbon 12 atom is 1.99 into 1.992648 into 10 to the power minus 23 gram. Again, we also know that the 1 mole of a carbon atom will have a mass of 12 gram. So this is important to understand. So the thing here is that we know that 12U is the atomic weight of carbon. Now, if we take the same numeric value and take that much gram of carbon, basically we are taking the 12 gram of carbon, then this 12 gram of carbon will be the mass of 1 mole of carbon atom. And this thing is true for every element. So two things we know. First, that the mass of one carbon atom is 1.992648 and the mass of 1 mole of carbon atom is 12 gram. Then how we will calculate the number of atoms in 1 mole of carbon? So it's very simple. So basically we are trying to calculate the number of carbon atom in 12 gram or 1 mole. So that will be 12 gram per mole divided by 1.992648 into 10 to the power minus 23 gram. per carbon 12 atom. Now, how we have done this? Let's see. Okay. So we know that 1 mole of carbon has a mass of 12 gram, and one atom has a mass of 1.992648 into 10 to the power 23. So, how many carbon atoms will be present in 1 gram? Okay, so we will just take the reciprocal of this. So we have taken 1 by 1.992648 into 10 to the power minus 23. Then this is the number of carbon atom in 1 gram. Then the number of carbon atom in 12 gram will be the multiple of the same. So 12 multiplied by the reciprocal of this will give you finally 6.0221367 into 10 to the power 23 atom per mole. So this is your Avogadro constant that we have seen earlier. I hope you are getting the point. So it is basically the number of carbon atoms which are present in 1 mole of carbon. And what is 1 mole of carbon? 1 mole of carbon is 6.0221367 into 10 to the power 23 atoms. Now, why are we using this mole concept? The question arises. We can simply count it. So why are we designating it as a number? The reason is that our atoms and molecules are very small in size, and it's very difficult to evaluate this large values. So for that, we have taken a unit of this and given it a constant number. So it is just for our convenience. This same analogy can be seen in our daily life also. While purchasing fruits like bananas, we refer the term dozen, which is equals to 12 number of bananas. The same thing has been applied there for referring 6.022 into 10 to the power 23 entities. We have taken 1 mole. Again, we have different types of units like score of 20 items. Score is for 20, gross is for 144. And from that same thing or from the same idea, we have the mole, which is applicable for microscopic level, like your atoms, molecules, particles, electrons, and ions. So, in our SI system, this mole concept was introduced for the convenience of handling of this large amount, and it was considered as the 7th base unit for the amount of substance. I hope you are getting the point of why we use this mole concept. Then, the amount of substance symbol N of a system is a measure of a number of specified elementary entities. And this entity can be anything. Like if I am saying that 1 dozen of carrot, then we will take 12 carrot. If we are saying 1 dozen of apple, we will say 12 apple. Although 1 dozen is more appropriate for bananas, we can use it for different type of things. But the count will be always 12, independent of the entity that we are counting. And the same thing is applied for the mole. So its count will be always 6.022 into 10 to the power 23 entities, whether we are talking about atoms or molecules or ion or electron or any other particle or specified group of particle. And no matter what the substance may be, we will say that 1 mole will have the same number of entities. Like if we are saying that we are having 1 mole of hydrogen atom, then we will have 6.022 into 10 to the power 23 atoms of hydrogen. As simple as that. Similarly, if we are saying 1 mole of water molecule, then what we are meaning? We are simply meaning 6.022 into 10 to the power 23 water molecule. So we are not focusing on the entity. We are just saying that, okay, if it is 1 mole, the count will be always equals to Avogadro constant. And again, if we are taking 1 mole of sodium chloride, then we will have 6.022 into 10 to the power 23 formula units of sodium chloride. Okay, since it is sodium chloride, so we are using the term formula unit. So I hope you got the point of using this 1 mole or the mole concept. Now, since we have defined the mole concept, therefore, it is easier to know the mass of 1 mole of substance. So what is the mass of 1 mole of substance? It is simply called as the molar mass. So the definition goes like the mass of 1 mole of substance in grams is called the molar mass. Now, a very important point where children often get confused is that what is the difference between the molar mass, the molecular mass, the atomic mass, the formula mass? So here, the only difference is their unit. So when we are telling molar mass, we are saying that we are dealing in terms of gram per mole. Okay. When we are saying molecular mass or formula mass or atomic mass, we are using U. So the method of calculation of each of these will be same, only the unit will be different. Hence, we can say that the molar mass of water is 18.02 gram per mole. If I ask you what will be the molecular mass of water, you will say 18.02 U. If I ask you that what is the molar mass of sodium chloride, you will say 58.5 gram per mole. Then what is the formula mass of sodium chloride? It is 58.5 U. I hope you got the point here. What we are doing is we are simply changing the unit. And what is this mass? This mass is for the 1 mole of water. And this mass is for 1 mole of sodium chloride. Hence it is called molar mass. So this was all for today's theory section. Thank you. I hope you enjoyed the lecture.